Hello, ladies and gentlemen. I'm from Security Department. My name is Haruki. Good to meet you all. Anybody related to security business? Could you raise your hand? If so. Not many. How about those who've been nagged by security departments? Who think that security departments being asking too much to you? There seems to be a lot of people feeling that way. So I would not touch upon anything cumbersome for you. Hope you enjoy my presentation. From Securities Division, I would like to share two stories. One is about the log platform regarding infrastructure security, and the other is anti-spam measures on full-line services. These stories are completely a separate story. Keyword is log analytics. Let me introduce how we analyze logs and make use of that log information for analytics. Myself will go through the infrastructure security topics. With infrastructure securities, we focus on server, network, and PC. Anything related to infrastructure, I'm responsible from a security perspective. And in order to ensure security on the infrastructure side, what kind of log do we collect? And how do we make use of that information? That's something I would like to touch upon in my presentation. And that log platform, we call it Monolith. With Monolith, we collect more than 40 types of logs coming from 30,000 or above data source. And the volume log is 600 million per day. In capacity, 1 terabyte. Server, PC, anything related to those with regards to the securities, some access log of the websites, and also network-related logs like firewall, antivirus, security solution, detection logs being collected. Those logs resided in each device. And because of the security incidents, in order for us to make some investigation, we had to access each different devices to check the information. And also, if the other department is involved for the use of the device, then we have to ask them to download the log, and it's going to take 30 minutes for us to receive that information. And sometimes the log is not kept for enough time, so sometimes we couldn't check the information we wanted to. So we had to consolidate the log first, so that we wanted to keep the log we need for the amount of time we want, so that we were able to reduce significant amount of time to do the investigation. And also we visualize the data, and we also use the data for analytic purpose. In 2014, we started this engagement. By using FluentD, we collect logs, and then we keep it in Kibana. And the log kept using Kibana, we visualize the data kept there using Kibana. But log information became more and more. There are more types of logs, and we started seeing lots of problems. And Kibana response was slower, Elasticsearch sometimes froze, or FluentD sometimes loses some logs. Last year, and in August, when we upgraded the Elasticsearch, we decided to rebuild all the systems as well. We changed FluentD to Logstash. Depending on the roles, we decided to separate servers, collecting logs or passing the logs. And also, we put Kafka in between so that we would be ready for the failures or maintenance. And whatever the data that's being passed will be sent to Hadoop and Elasticsearch. And the log that's sent to Hadoop won't be erased. And we use it for backup purpose or use it for big data analytics. And the data sent to Elasticsearch, we visualize the data, or we use the data for investigation. And also, we use it for real-time analytics. Human beings get information of 83% out from their vision. Systems, security status. If we visualize those, people can easily understand what's going on. And also, what's the normal state? What's the abnormal state? Visualization can help you decide or judge the situation. I would like to give you a couple of examples here. For example, if PC is infected with malware, attacker would spend time to collect information of the company. The attacker is targeting our important information, like customer information, or file server with lots of information inside, or the admin server that controls PC. Before that, PCs that they target, or they're trying to find out which PC belongs to the admin. And using PC-infected malware as hub, they expand and permeate malware, or they try to use remote desktop. Let me focus on the status of the remote desktop use. If remote desktop information happens with each PC, that information gets sent to Monolith on a regular basis. The collected information might have domain names or user names or PC names, and we create dashboard based upon those information. And we can identify how much of an access happening per day, which PC is being used the most, which user is most active. We identify the status by looking at the information. And on PC, if there is some anomaly or suspicious communication happening on PC, we can check the remote desktop status. We can check the details so that we can compare now with the past. We can compare now with the normal state so that we can identify whether the situation is abnormal or not. And in case of Linux server, we pay attention to SSH communication. If malicious SSH becomes successful, that is quite damage to the company. So basically, we ban the access of SSH inside and outside of a company, but there are some exceptions. So we have to make sure that we understand the situation of use. We collect the server authentication log, and that's sent to Monolith so that we can visualize the data. And which system had the SSH communication to our servers? Is it successful? Did it fail? We're always monitoring the status. And if there is a malicious communication happening on the server, we check the status of SSH. Is there any anomalies happening on SSH side? And also, PC process, wireless authentication, FTP login information, VPN access. All these are visualized, and we monitor the information. By looking at the dashboard, people can identify the anomalies. But there is a limitation with human eyes. There's so many dashboards. To identify anomalies, that's just too hard for humans to do. We were thinking of automating this process, and that's what we did last year, trying to find the right solution. And defining the normal. It might be different depending on the situation. Server, PC, network equipment, dependent on the device types, the normal state changes during the business hours or weekends or morning, lunch, and evening. Things change. So we had to think about all these cases, and we went through trials and errors. And Elasticsearch started to offer machine learning beta version last year. And we compared the machine learning features with our existing mechanism, and we liked it. And what we wanted to do can be supported by Elasticsearch machine learning feature. So we decided to introduce the Elasticsearch machine learning feature when they released it in May. This is the firewall IDS log volume analytics. Compared to the normal state, how much of an anomaly happening, you can see it in scores. If once it's detected as abnormal, then it could be DDoS or network scan. Or service promotion sometimes increase the traffic, and that sometimes was the root cause. And by using this machine learning feature, remote desktop use can be analyzed as well. PCs that you don't usually use, or users who are not too active, if they use remote desktop, then you can detect that. And also for SSH access, or PC process information, or VPN use, all these can be analyzed as well. And by using machine learning feature, alert quality went up. In the past, we were using the number for setting up a threshold, but a constant was not good enough. By using machine learning, we look at the time, device types, and we can receive the alert depending on the situation. We use Line for our business. And there are two reasons why we use Line for business. We can contact the person in charge at night if we use Line. And also, even during the weekends or holidays, we can contact these people. With Elasticsearch, there's a watcher feature available where we can allot any things. As an action, there are a couple of features available, and one of them is called Webhook. We can collaborate between Webhook and Line Notify, integrate the two, and group or individual can receive a lot by integrating these two. And also, we're collecting logs. We visualize the data, we analyze the data, and we issue a lot. So that's how far we came. And for the future, we will focus more on actions so that we can automatically delete the malicious communication or malicious files. So log platform becomes a core to control the security. So we will be more focusing on the orchestration. That's all from me. So now we would like to talk about anti-spam measures.
Going forward, I'm going to introduce anti-spam measures and features that is being conducted in Line Talk Room. I'm Aiko from Line Security Team. Just like emails, on daily basis, a lot of spam messages are being sent. So we're going to introduce you with the current status, how we analyze these spams. And next, I'm going to introduce the system that has been developed and used for this measure to reduce the spams. First, this is the data going back from November 2013 to the recent data. These are the reported spam messages and the trend of the report count. Occasionally, there's some irregular data where you see spikes of the number of reported messages. But basically, after this anti-spam measure is implemented in 2013, in 2015, it has stabilized and flattened out up to leading up to today. Excuse me, the slides seems to be off. Please move the script forward. Okay, thank you. Sorry about that. In Line, there's a report feature, and if a user receives such messages, they can report it as spam. So we will compile these reported messages and analyze and confirm whether these are actual spams. If they're confirmed, these will be put into our database and utilized in the future spam detection. This is the number of reported spams by countries. It may come as a surprise, but the number of largest reported spam messages is not Japan, but it is Taiwan. So, however, because Japan also has significant number of spam messages, we're working on the anti-spam measure, especially on these two countries. And also recently, we're seeing increase in reported spam messages in other countries. So right now we're expanding our effort in combating these spam messages. So here, these are the typical patterns of spam messages. Some of these messages are obscured. And depending on some countries, they have different trends of spam messages. For example, in Japan, it's mostly for the solicitation for dating sites. And the spams are sent via friend request. And on the other hand, for Taiwan, most of them are on advertising of the products and services, or advertising for copied brands or financial services, where they're trying to entice the users to sign up. I just showed you two types of cases from Japan, Taiwan. And we're also analyzing spam messages from different countries, and we're seeing different spam messages, different type of spam messages from different countries. So this is my guess, but I believe that spam messages are different depending on countries and cultures. So once you ban the spam message, you may think that since Line account is tied in with phone numbers, so by blocking the account, the spamming account can be reduced. However, currently Line accounts can be created using Facebook accounts. And also, you may think that phone numbers are quite difficult to obtain, but there are many cases, especially in overseas, where the phone numbers can be applied and obtained in large volumes. And also, they don't cost too much. So those are the phone numbers that will be used to create spamming messages. And once they get blocked, they'll come back and create a different account. So this is a cycle. So this is how it sees how the flow goes. Once it gets blocked, a new account gets created, and additional spams can be sent. As Haruki has mentioned earlier, even for spamming, we are gathering various data from various servers, and we're analyzing these data using Elasticsearch and Kibana. And this is how we visualize this. So this is very useful in a way that it's easier for human beings can analyze. And we also have implemented features of machine learning. So maybe in the future, if there's an irregular number of reported spam messages, this will be reported and reported via Line Notify. Continuing on, I'd like to show you how these are being analyzed. And based on the results that we found from the analysis, we implement those in the development and of the system, and I'd like to go over how these are being developed. First, this is the flow chart for the blocking spamming accounts. So there are three major rules. One is rule-based filters, machine learning-based filter, and the third one is a user-based filter. Here, the filters are in the vertical direction. You can see this green line and red line. Each of these are blocks. So first, the spammer will register the account, add a friend, and then send a message. This is the overall flow of how the messages are being sent. And at each stage, the filters are being applied. For example, for rule-based filters, if there's a addition of 1,000 friends in 1 second, this is not possible by human hands. So this will be blocked. So this is the example that I just mentioned. That for certain conditions, we have implemented multiple conditions where once they are valid, the messages are being blocked. Here, where you see this log signs, so the first one has not yet sent a message, but at this point, we cannot see the message itself due to security. So we're looking at the metadata, the timestamps, and we apply these block rules, block and block, based on these metadata. Once the message is sent and the user reports the message as spam, the message itself will be sent to a line. Here we will analyze the message itself, but here we also perform a machine-based analysis. But eventually, then we'll do the machine learning-based analysis. And eventually, this analysis will be conducted by human eyes. So going back to the previous screen, so once the message gets reported by the user, then the message, we will look at the message itself to make a judgment. So here, we have presented the blocking flow in the different chart. So this red part is the blocking done by metadata without looking at the actual text, actual messages. But the green part is where the message content is actually being analyzed. And also, this is not included in the chart, but the first two blocks are done automatically, and the last block is done manually. So for rule-based blocking, as I said earlier, we'll look at the number of messages, number of friends being added, whether they're using the virtual phone numbers. We'll also look at the friend charts, other various parameters, and these filters are applied based on these rules. Next, I'd like to talk about the machine-based learning, machine learning-based filters for the rest of the presentation. These are all automated, but based on the reported data, the classification tools are created in real time to create new filters. So the systems are created by humans, but running of the system will be done, which involves learning and detection, will be conducted automatically. So after we accumulate such spam messages, so these are the reported messages, and for those reported message, we'll make a decision whether these should be blocked or not. Obviously, not 100% of the spam messages are actually a spam message. We found out that 80% of them are spam messages, and the remaining 20% are reported by mistake, or it could be something that they had a fight with a friend, and they designated such a friend's account as spams. So we need to classify whether these are actual spams or not. A simple way to make a classification is if it involves a large number of friends, this will be included in the spam clusters. And the messages that does not involve multiple accounts will not be classified as spams. So once we can classify these, we will run through the machine learning algorithm for general classification. So here you see how the data is being sent to the filter and the messages are being filtered. And based on these spam messages, new patterns are being learned and then applied to the new filter. So based on the security point of view, the spam messages are different, for example, from 10 years ago compared to today's spam messages. This is called a concept drift. And in order to accommodate these changes, these learnings have to be done in real time. So this is how we run our system. So if we implement these new policies, actually the spammers will think of a workaround. So this is like a cat and mouse game. However, by automating this cat and mouse game, we can reduce the limit of the amount of time that people are actually working on the system, as well as the cost. For rule-based filters, fundamentally, there will be for the code where it can be determined regardless of the timeline, where it can be determined as a spam message. The machine learning-based filter will actually apply the block. But for machine learning filters, we actually look at the timeline aspect. One of the weakness of machine learning-based filter is spammer will try to pollute such system. For example, spammer has a large number of accounts, so the spammers will actually learn how to avoid these blocks. So by sending a lot of legitimate messages as a spam messages, this will create more false positives. So the machine will actually learn normal messages, and this will yield to a large number of false positives. in the security scene, this false positive, the number of false positive could be an issue, and we need to reduce this such cases. And it is almost impossible to reduce it by 100%. But most of these attacks are being done indirectly. So it is very difficult for the spammers to figure out whether this is actually working. And we have actually seen such attacks, but this is not very common. So by adding some simple conditions in learning, this can be countered. But we are not quite sure if this will work for the future. And lastly, I'd like to comment on monitoring where actual judgment is being done by humans. So the machine learning blocking is done by the machines. And there we can reduce 80 to 90% of the spam messages. The remaining 10 to 20% are done by the human judgment. So we need to keep the false positive to 0 with the machine-based filtering. So this is not enough to have a number to under 1,000s. So we're trying to avoid the cases where the legitimate users gets blocked as a spam. So we're leaning toward on the side where we will have more false negative than false positive. So we actually have introduced some margin of error to allow this to happen. And so to summarize, I have introduced the current state of spam messages, and we've also highlighted that spam messages are increasing all over the world. And for the analysis, we use Elasticsearch and Kibana. And we also use alert tools to counter these spam messages. So what we're doing right here is not for the data analysis. What we're aiming for is to automate this data analysis so that we can run something that does not require too much of human interventions. So I myself is not an expert on machine learning, but this is what we have in our mind when we implement and execute these systems. That's it for my presentation. Thank you very much.